You might expect that the heavy snowfall is a main requirement for the formation of a glacier, but if you step and think about it, you realize that there are lots of areas of the world that receive huge amounts of snow but have no glaciers. Snowfall alone isn't enough. For a glacier to form, the snow can't melt. It has to be conserved. In the extremely cold Arctic and Antarctic, there are large areas that receive minimal precipitation and actually qualify as deserts. Also, this little snow, they're massive as shit because the snow doesn't or is conserved and transformed into ice. Of course, lots of the places do get large amounts of snow, and they do have glaciers, high mountains, for example. In high mountains, where the climate is humid and cold, snowfall is frequent. Above the snow line, the annual snowfall exceeds the annual melting, so snow builds up. The accumulation is thickest in the hollows that has varied because these locations are relatively high and cool, and are protected from sun and wind. A sunk in the hollow is gradually converted to ice. Flows of fragile snow crystals break as they are compressed by the weight of more snow settling on top of them. There is some melting and refreezing because of the compaction, earth heat, and seasonal temperature fluctuations. As the snow crystals are broken, then they are wetted by meltwater and refrozen over and over again. Gradually, over time, the snowflakes change into grains. They become rounded and granular, like the grains of cold sugar. There are pockets of air between the grains, connecting the grains to one another. This old snow, called firn, is generally created after one complete winter-summer cycle. Firn is actually a bit of ice. The firn begins to recrystallize and eventually it combines and crystallizes into solid ice, glacier. What happens is the small grains coalesce to form a large interlocking crystals with air trapped as rubber inside the crystals. In the end, it's pure ice, with all the air squeezed out. The flow of the glacier down the mountain contributed to crystal growth as the movement helps to compress the air out. As the hollow in the valley has filled with tuning to ice, the hollow enlarges, and the rock walls are carved out by shifting ice. As new snow is added, the lower part of the snow and its mass bulges out, kind of like a mud pie. As the mass continues to bulge, part of the ice moves over the edge of the hollow and down the valley. Large glaciers usually move faster than small ones. Also, the movement is faster in the summer when more meltwater is present beneath and around the ice mass to lubricate it and buoy it out. Most valley glaciers move at a rate of between a few inches and a few feet a day, but some glaciers, called surging glaciers, can travel as much as 300 feet a day. There are at least 200 of these surging glaciers in Alaska and Northwest Territories. The surging is caused by a number of conditions like sudden adjustment to an increase in snow load on the top, more likely, or an increase in projectile melting due to a rise in temperature. Glaciers that hold more weight are better lubricated and tend to move faster than drier ones. In very cold climates, glaciers are quite dry because of the lack of melting. The amount of water is slight, so that the glacier does not slide as quickly. In warmer climates, glaciers are better lubricated with meltwater. They also cause more erosion and more calving out of the valley floor. This is because during the melt freeze cycle, parts of the glacier freeze to the bottom and sides of the valley, and then the ice moves on. Large chunks of glacier break out rocks. Warmer climates have a greater impact on the landscape than those in very cold climates.